Okay, I'm going to work a final few problems from the extra practice on Chapter 8. I'm going to start with number 38. We have 3k squared minus 10k plus 8. We're going to use that AC method that I introduced in a previous video. We use the acronym MARF, M-A-R-F. The M stands for multiply A times C. Here's our A, which is 3. Our C is 8. 3 times 8 equals 24. All right, the A says add to B. That basically means I need two factors of 24 that add together to make B. In this case, a negative 10. 1 and 24 won't get it. Negative 2 and negative 12 don't get it. Negative 3 and negative 8 add to negative 11. Negative 6 and negative 4 add to negative 10. So we're going to have negative 6 and negative 4. R stands for rewrite B using the factors. All right, so we're going to rewrite this negative 10k using negative 6 and negative 4. So 3k squared minus 6k minus 4k plus 8. We rewrote our B term using these factors. All right, and the last letter in our acronym F stands for factor by grouping. We're going to group together our 3k minus 6k, our 3k squared minus 6k, and our negative 4k plus 8. We'll start with this one. We're going to factor out 3k here, and we end up getting k minus 2. And then here we're going to factor out a negative 4. Negative 4 times k minus 2. All right. And then we notice in both of these terms we have a like factor that we can factor out. We have k minus 2. When we factor it out of the first term, we get 3k. When we factor it out of the second term, we get minus 4. And these are our two factors for this trinomial 3k squared minus 10k plus 8. We can check that by foiling. K times 3k is 3k squared. And then the outer negative 4k minus 6k. And then plus 8. When we combine our like terms, we get 3k squared minus 10k plus 8. And it matches. So those indeed are our factors. All right, moving on, I wanted to solve for you one of the, I'm sorry, I wrote the wrong number. On 49, I didn't actually assign this one, but I do want to solve a difference of squares because it's really important to recognize these special cases of polynomials. We notice that our first term is squared and our second term is squared. It's a negative, so this is a difference of squares. If we follow that model, we know that we have y minus 6 times y plus 6, because 6 is the square root of that second term, y is the square root of the first term, and that is our answer. This is one of the simplest polynomials to factor, the difference of perfect squares. All right, the last problem that I'm going to work tonight is number, let's see, let me do 54. And it is 27x squared minus 36x plus 12. All right, the first thing that I'm going to do is I'm going to look for a common factor in all of these, and I can see quickly that 3 goes into 27, 36, and 12, so I'm going to factor out a 3. When I do that, I get 9x squared minus 12x plus 4. Immediately, I notice that I have a perfect square here and a perfect square here. So I'm going to rewrite this. I'm going to write this as 3x squared minus 2 times 3x times 2, and then write this one as 2 squared. So basically I'm showing this is my A, this is my 2 times A times C, or B, I'm sorry, and this is my B, all right? This is the form of that perfect square trinomial that we learned about in lesson 8.7. And when we have this, we get 3 times A minus B, squared. We're going to fill in our A's and B's now. 3 times 3x minus 2 quantity squared. And that is our answer. Looking for those special cases on the trinomials and the polynomials when you're factoring is really important because it makes your factoring so much easier. If you have a difference of squares and you follow that model, you can quickly come up with the factors. If you have a perfect square trinomial here and you follow the model, you can quickly come up with the factor. It makes things so much easier. Okay, those are the final problems that I'm working from the extra practice. I hope that these have helped you. We will be going over the MARF method again tomorrow in class. We will also go over some word problems in class. Have a great evening.